In this video, we'll be solving a rate word problem. Joe can wash 3 cars in 5 hours, and Merle can wash 4 cars in 3 hours. 15 cars need to be washed. If Joe works for 2 hours and is then joined by Merle, how long will Merle and Joe have to work together to finish washing the 15 cars? Now, what we need to do to solve this problem is use the idea that rate times time equals amount of work done. So since we have 2 people working on the car wash, we'll use Joe's rate, and I'll show that with R sub j, times Joe's time, so T sub j. And so this is the amount of work that Joe gets done, and then I'll add to that the amount of work that Merle gets done. So I'll use R for Merle's rate, R sub m, times Merle's time, so T sub n, and that's going to give us the total amount of work done. All right, now let's read our problem and see what we can find to fill into our equation. Joe can wash 3 cars in 5 hours. This gives us Joe's rate, and we can just show it as 3 cars in 5 hours. So technically this is 3/5 of a car per hour. Rate is usually per unit of time, so he can do 3 cars in 5 hours, or 3/5 of a car per hour. Let's go ahead and see what Merle's rate is. It says Merle can wash 4 cars in 3 hours. So Merle's rate is 4 cars in 3 hours, or 4/3 of a car per hour. Right? We have 15 cars need to be washed. This is the total amount of work that needs to be done. So that's going to go over on the right side of the equation, 15 cars. And then if Joe works for 2 hours and then is joined by Merle, so Joe is working 2 hours longer than Merle is working. So Joe's time is going to be some time plus 2. And we don't know about Merle's time, so we'll let that be T. And then this Joe's time will be T plus 2. So when I solve, and you may want to write this as T sub m, and that way you know that, in fact I think I will, T sub m, because that'll be Merle's time once I solve for that. All right, then the final question, how long will Merle and Joe have to work together to finish washing the 15 cars? So you'll notice that our equation only has the one variable, which is T sub m. So I can go ahead and work this equation. Let's distribute this 3/5 through the binomial. So I have 3/5 times T sub m plus, and then 3/5 times 2 is 6/5, plus 4/3 times T sub m. I'll just write that as 4/3 T sub m, and that equals 15. Now I'm going to go ahead and multiply through by a number that will cancel these denominators off so that I can work with whole numbers. Looks like 15 will cancel these off. So if I multiply every term, getting rid of the denominators, 5 divides 15 3 times. And again here, 5 divides 15 3 times. 3 divides 15 5 times. And then that's all the canceling. So now what I have is 3 times 3 TM, so 9 TM plus, and then 3 times 6 is 18 plus 5 times 4 is 20 TM, and then 15 times 15 is 225. Now I can combine these two terms and get 29 T sub m. And let's go ahead and subtract 18 from both sides to get this constant off the left side. And 225 minus 18 is 207. Divide both sides by 29. And Merle's time then is 207 over 29, and that's in hours. Or 7 hours and 4/29 of an hour. Now to see if we answered the question. The question was, how long did they have to work together? Well, the 2 hours that Joe is working, that's just him by himself. So we want the time that they're working together, which means we need to give Merle's time. So this is the answer.